So right now, we're talking about the different methods we have to solve quadratic equations. What's one method that we had that you guys just practiced and did? Factoring. Okay, so there we go. Factor the equation and use the zero product property. That's the first way that you could solve an equation, a quadratic equation. But what if it's not factorable? Did we learn another thing that we can do with standard form to get it into a solvable equation? If it's in standard form, I could go to vertex form by completing the square. So that's another way that we could solve it, is we could complete the square and then solve the equation. So if it's not factorable, that means that our solutions are irrational numbers. Irrational numbers are decimals that don't repeat or stop. Can you guys think of any numbers you know that are irrational? 1.25 stops though. 1/3. Pi. Yeah, pi is an irrational number. Any other ideas? 1/3 would be rational. So irrational comes from the root word ratio, and ratio means fraction. So if you can write your answer as a fraction, that means it's rational. If you can't write it as a fraction, that means it's irrational. So pi cannot be written as a fraction. What do you think, Gabe?
Isn't there one that's like supposed to be the square root of 1?
You're thinking imaginary, but you're close. How about a square root of 2? Is that a whole number?
No.
No, so that would be an irrational number. I can't write it as a fraction. It'll be a decimal that never repeats and never stops. Square root of 3, same thing. Square root of 4 is 2, so that wouldn't count. Square root of 5. So all of those square roots that aren't of a perfect square, those will all be irrational. And then numbers like pi, also irrational. Okay, so we're going to solve this quadratic below for x. My quadratic equation is x squared plus 4x minus 5 equals -2. Is it equal to 0? Let's make it equal to 0. So the first thing I'm going to do is I'm going to add 2 to both sides. And I will get x squared plus 4x minus 3 equals 0. So there's my step. Add 2 to make the equation equals 0. Remember, it's always helpful if you write down the annotations, like what I did in addition to the math work. Okay. Now, I will tell you right now, this is not factorable. I cannot find any two numbers that multiply to a -3 and add to a 4. So when I can't factor it, the next option I have is to complete the square. So completing the square is how we go from standard form to vertex form. So now we're going to set up the completing the square. So just a quick reminder, when you are completing the square, you put your x squared in the bottom left, you split your x's in half, and you put half of them on each diagonal. And then I'm going to put -3 on the outside, equals 0. I'll give you a second to write that down. Okay, so completing the square is going to give me x plus 2, x plus 2. What's 2 times 2? 4. So that means to fill it in, I'm going to need to add 4. And then to balance it, I'm going to need to subtract 4. All right, so there I just completed the square. And if I do that, my vertex form of my equation is going to be x plus 2 squared. What's -3 minus 4?
-7.
-7 equals 0. Okay, now when it's in vertex form and I only have one x, I can undo to solve. So that means that I can undo the -7 and undo the squaring and undo the +2. So I don't have to have it factored in zero product property. I can use my usual solving steps. So that's what I'm going to do next. I'm going to start to solve. So first, I'm going to add 7 to both sides to get rid of that -7. That's going to give me x plus 2 squared equals 7. How do I get rid of squaring? Square root. Okay, so now when I square root my parentheses squared, I'm left with what's inside the parentheses. When I square root 7, is that a perfect square? No, it's not. 7's not a perfect square. No, it's so since it's not a perfect square, I'm going to put it into my calculator. You guys have a calculator. Someone tell me what the square root of 7 is.
2.64.
2.64?
Yes.
Okay. So this means if I square 2.64, I'll get 7. What other number squared would give me 7 though? Because I'm going to get 2 answers here. What other number would give me 7 when I square it? How about negative 2.64? So when you're doing this, don't forget to do the positive version of the square root and the negative version of the square root. And that's how you get your 2 answers. Okay, how do I get rid of +2? Subtract 2, and that gives me x is approximately, thank you, x is approximately 0.64, or if I subtract 2 here, I get x is approximately negative 4.64. You guys know what those squiggle equal, or yeah, the squiggle equal sign means? It means your answer is rounded. It means it is what we call the approximate answer. The approximate answer is the answer in decimal form. So this would be your approximate answer right here. If you forget to put the squiggle equals, that's okay. All right, what if I wanted to put it in exact form though? Because exact form is more exact. That would mean we leave the square root as a square root. So what that means is when we're solving it at this step, when we're taking the square root of both sides, then I would have x plus 2 equals the square root of 7, or x plus 2 equals the negative square root of 7. And that negative sign isn't under the square root. I know you guys think, oh, you can't do a square root of a negative, but this negative is out front. So then when I subtract 2 from both sides, I get x equals negative 2 plus the square root of 7. And then over here, I would have x equals negative 2 minus the square root of 7. And that is what we call exact form. Because I did not round anything, it is exact.